All right, let's take a look at functions and more functions and things that you can't spell fun without. I think I have that backwards. Let's remove you. Let's put you here and make you red, and away we go. A relation is it's a good start, is a function if x values do not repeat. X values, also known as domain, also known as the input. They all mean the same exact thing, but they're not allowed to repeat. So let's see what my x values are. You're a -3, you're a -2, you're a -5, you're a -3, and 7. You see how that -3 repeats as an x value? If an x value repeats or is used more than once, it is no longer a function. So this relation here is not a function because x values cannot be used twice. Every x value is mapped to exactly only one y value. Okay, x value is not allowed to repeat. So this is not a function, again, because that -3 is used 2 times, as opposed to what the Fugees would say, 1 time. It's a song from the 90s, look it up. So I have to figure out if these are functions or not. Well, again, if x values repeat, then they're not a function. X values, also known as the domain, also known as the input. See that x value right there, -35? See how it goes to 2 different members of the range? 2 different y values? That means that that domain, that x value right there, just repeated. So this is not a function. I don't care how many times the y values are used. So you might be looking at that 1 right there and say, oh, that 1 is used twice. I don't care. I don't care if the 1 is used twice. I only care if the x or the domain or the input is used twice or 3 times or 4 times or whatever. Is this a function? Well, you're an x and you're only used once, and you're an x and you're only used once, and you're an x and you're only used once, and you're an x and you're only used once. It's a function. It's a function. Right? I see you, function. And I see you, students. Make a mapping diagram and find out if it's a function. Okay? The way you make a mapping diagram, and the words that they use here are, instead of domain and range, they use input and output. So I'm going to do the same thing. I'm going to, let me actually erase that. I'm going to do my input in blue. And you have to make sure your numbers are in order. So I have 3, 4, 5, 4, 10. So the smallest of those is 3, and then 4, and then 5. 4 is used again, so I'm not going to write it out again. And then I have 10. That's my input. My output, which I'll do in red, is already in order. That's good. And that's 0, 7, 10, 14, 25. 3 goes to 0. How do I know that? Because over here it says 3 is matched up with 0. That 4 is going to go to 7, straight across. That 5 is going to go to 10, pretty much straight across. That 4 goes to 14, so bad things happen. And 10 goes to 25. Is this a function? No. Why? Because that 4 in the input, which is an x value, which is a domain, is used twice. 4 is used 2 times, which means it's not a function. Again, I don't care how many times an output is used. I only care how many times an input is used. Ooh, look at this Common Core problem. Hold on, let me grab this thing. Just pulled it up. You like that? The set of ordered pairs below represents a relation. So I have 0, 2, 1, 3, 1, 4. Well, it's not a function because 1 is used twice here. 2, 5, and 3, 5. So I don't have a function because that 1 right there and that 1 right there is used twice. So which statement is true? Okay. The relation says function. No, it's not. The relation is not a function, but removing 1, 3 and replacing it with 2, 6. All right, let's see what that looks like. Removing 1, 3 and replacing it with 2, 6 would make the new relation a function. Well, no, it wouldn't. Because if I did that, then that 2 and that 2 are used twice. So, no, that's not true. It's not true at all. It's a lie. The relation is not a function, but removing 1, 4, okay, and replacing it with 4, 1 would make it a function. Okay, so let's see what I've got here. Let's see if any of my x values repeat now. 0 is not used as an x again. 1's not used as an x again. You're dead. 2, 3, 4. Hey! It's a function, baby! And what D does is D replaces a 3x value with a 3x value. And so if you were looking at D just to make sure, D just says, hey, get rid of this, get rid of this, and then make it 3, 6, and now it's a function. Well, no, it won't be a function because 1 and 1 are still used twice. So that won't help. So D would be wrong anyway, just to cover our bases. Okay. Write a function rule for each. Write an equation. Remember, function rules and equations are the same thing. Whenever you see the word output, okay, output means a y value. Input means an x value. So here it says the output. Okay, well, the output means y. Is means equals. 1/3 means 1/3. Of the input means times x, so 1/3 x. So y equals 1/3 x. Done. Dunzo. Oh, why did I do that? The output, y, is 3 less than. Ooh, here's the tricky thing. A little trick that I like to use is whenever you see the words than, swap the two things on the other side. So on the right side, first off, it's less, so it's a minus. Okay. 3 is now going to go on the right because you're taking away 3. When you're taking 3 less than, you're taking away 3. Twice the input means 2 times x or 2x. Okay? So that than word is a word you want to keep an eye on. Charles. Well, that's not output or input. Oh, Charles. I'll just use C. Is always equals 2 years younger than. There's that than again. So 2 years is going to go on the right side. Younger than John, which means John is going to go over there. J for John. Andrea or Andrea makes is $13.50. So $17, and 50 cents per hour. Per means times. So times an hour each. Okay. 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 Make a function rule. All right. Well, There's a website that you can use, which is the NCTM website. That what I'm going to do for this video is just like embed it in here. Go to Google and type out NCTM line of best fit calculator. Click obviously the first screen, add point, add point. You can click on the show the line of best fit and it gives you the equation for the line of best fit. But let me show you the long way of doing this. Let me show you the long way of doing this. Don't forget, there's a way. If you want to do this the fast way, Google search, and maybe I won't embed it. Google search NCTM line of best fit, and it'll give you. It will give you a website where I go over how to do all of this. Okay. Make a function rule. Here's the long way of doing it. This is what you have to do. You have to write out an equation in y equals mx plus b form. This is the long way again. This is the bad way. I have to find my slope. My slope is m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. I'm going to pick 2 points, 1, 1, and 2, 2. 1, 1, 2, 2. In order for me to find out what my slope is, I'm going to label those points x sub 1, y sub 1, and x sub 2, y sub 2. And then I just plug everything in. Y sub 2 is 2 minus y sub 1 is 1. X sub 2 is 2. Again, minus x sub 1 is 1. 2 minus 1 is 1. 2 minus 1 is 1. 1 divided by 1 is 1. So my slope is m equals 1. So what I have so far is I have y equals 1x plus b. Okay. Now I have to find b. What I do is I take any of my points. So why don't I just use that point right there? I take any of my points and I relabel any of my points x, y. And I plug that guy into that equation. So y is 5. 5 equals 1 times x. Well, I don't need that 1 there. So 5 plus b, subtract 5, and then b will equal 0. So if what I have is y equals 1x plus b and b equals 0, then I have y equals 1x, which is just x, plus 0, which is nothing, and that's my answer. Y equals x. That makes sense because look, see what x is? Y is x. See what x is? Y is x. See what x is? Y equals x. It's the same thing. That made sense. That was pretty easy. Let's do it again. The long way. Again, the easier way, Google search NCTM line of best fit. And then you'll get that website and you can just type all of these in and then click on the button that says line of best fit. You're done in like 5 seconds. But I don't know. I like to make life a little bit miserable. So why don't I just do it? Same exact procedure. I have to find out what my slope is first. So that's my slope formula, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. I don't like those negatives. Let me pick these points because they're positive. 110 and 214. X sub 1, y sub 1, x sub 2, y sub 2. Plug them in. Y sub 2 is 14 minus y sub 1 is 10 over x sub 2 is 2 minus x sub 1 is 1. 14 minus 10 is 4. 2 minus 1 is 1. 4 divided by 1 is 4. So m equals 4. If m equals 4, then so far I have y equals 4x plus b. Well, what's b? Well, b is my y-intercept. However, looky over here, whenever x is 0, that number is my y-intercept. So that crazy thing where I had to pick a point and relabel things and plug them in and get b, I don't have to do that because I just found out that b is 6. So put it all together, and I have y equals 4x plus 6. Ooh, baby. Much nicer. Much nicer. Much nicer. Make a function rule. I'm not going to use... Listen. Yes, y equals mx plus b. But remember, m stands for the slope, and b stands for the y-intercept. So why don't I just use rise over run and see what I'm looking at to find the slope and the y-intercept? Let me pick 2 points, that guy and that guy. Let me look at my graph. Everything goes by 1. Everything's normal. And so if I go up 1, 2, left 1, 2, I have since it's up and to the left, I have a negative slope, and it's negative 2 over 2, so my slope is negative 1. My slope is negative 1. Look at that guy right there. Remember, when x is 0, that guy right there is my y-intercept. So my y-intercept is 1. So if I just found out that m is negative 1 and b is positive 1, then I can take my equation right there and say y equals m, which is negative 1, x plus b, which is positive 1. And I don't like that negative 1 floating in front of x. If I have negative 1x, then I just have negative x. That's how you're usually going to see it. Not that putting the 1 there is wrong, but you're rarely going to see a teacher put the number 1 in front of a variable. It's not going to happen. If you're like, could I just have used the lin-reg calculator thing that you showed me twice now? But why? Why would you do that? Don't do that. Don't do that. The graph shown below represents the rate at which water drains from a tank once a drain is open. All right, so let me just make believe that I don't see that this is a multiple choice thing and see what I can do. Okay, I'm going to come up with the equation to this guy. Y equals mx plus b. These numbers go up by 1s like they normally do. So if I wanted to find a slope, I'd put a dot there, and I'd put a dot there, and it goes down 1 over 1, 2. So my slope is down and to the right, which is negative 1 over 2. My slope is negative 1 over 2x plus 14 because my y-intercept is 14 there. Now, what this means in the real world, is whenever you have a number in front of x, that is your slope. That's also your rate. So my rate is going to be the y value over the x value, gallons per minute. And what I'm doing is, since it's negative, I'm decreasing half a gallon per minute. Okay, again, the number in front of your x is your slope, and the slope is the same as a rate. So the number, since it's negative, means I'm losing, I'm decreasing, I'm removing 1/2. 1/2 what? Well, remember, rate is y per x. So gallons of water in the tank per minute that the drain is open. Gallons per minute. I'm losing half a gallon per minute. What does 14 mean? 14 is what happens after I've done nothing. So if I've drained for 0 minutes, which means I haven't drained yet, I have 14 gallons. So this means I have 14 gallons, okay, in the beginning. So I begin with 14 gallons. Now let's look at my options. I lose half a gallon per minute, and I start with 14 gallons. Let's look at my options. The water is draining at a constant rate of half a gallon per minute. True. The tank contained exactly 14 gallons when it was opened. That's also true. That was easy. Let's make sure that these don't make sense. The water is draining at a constant rate of 2 gallons per minute. No, it's half. The water is draining at a constant rate of 5 gallons per minute. No, it's half. And the water is draining at a constant rate of 14 gallons per minute. No, 14 is what I started out with. Even though this part is true, these guys are wrong. That guy is wrong. So there you have it. Remember, when you're dealing with real life problems and you come up with an equation like I just did, okay, the number in front of x is your rate. It's your slope. The number floating around all by itself is your y-intercept. That's what you start out with. Two linear functions of x are shown below. Okay. Two linear functions of x are shown below. So function 1 is that guy. Function 2 is a chart. So what I'm going to do is I'm going to use that website that I told you about because these numbers are ridiculous. Can I switch over? No, I can't. No, I can't. So what you can't see is that I'm on, well, can I use this? Let me see if I can use good old Siri to do it for me. Let me see if I can use my calculator. I'm typing into my calculator NCTM line of best fit, enter. Look at that. If I scroll down, look at that. I don't know if it's backwards for you or not, but I'm going to type in those points. Negative 12. I can't find my negative. Negative 12. Negative 331. 311, I mean. Add point. So on my screen, it shows up as backwards. So it might show up as backwards for you. I'm not sure. But you get the idea. Negative 8. Negative 211. Add point. Negative 3. Negative 86. Add point. And 114. Again, it's showing up backwards on my screen. But if I scroll up and click on show the line of best fit, it shows me y equals 25x minus 11. Y equals 25x minus 11. This guy is y equals 25x, what did I say? Minus 11. So that's function 2 now. That's function 2. What am I supposed to do? Which statement about the function is true? Well, I have, okay, well, let's just, function 2 can be described by the equation 35x minus 109. That's not true. Function 2 can be described by the equation y equals 100. That's not true. The y-intercept of function 1, it's that guy, is less than the y-intercept of function 2. The y-intercept of function 1 is 19. The y-intercept of function 2 is negative 11. 19 is not less than negative 11. So it's got to be D, but let's just make sure. The rate of change of function 1, which is 30, is greater than the rate of change of function 2. That is true. The answer is D. Okay. Crazy Common Core problems are going to get us every time. Speaking of which, last one. Sophia boarded a bus to school on the bus stop. The distance traveled by Sophia's bus is represented by the graph below. Let's turn it into an equation. So let's put a dot there. And I can't tell, so I'm going to put a dot there. That makes me nervous. I'm going to put a dot there. All right, so when I come up with an equation, it's always y equals mx plus b form. I'm going to go up 1, 2, 3, 4, 5, 6. So my slope is up 6. Now look, when I go to the right, I don't go right 1, 2, 3, 4. I go right 2, 4, 6, 8. So I'm going to go right 2, 4, 6, 8, 10. So 6 over 10. So my slope of 6 over 10 is when I divide both of them by 2, 3 over 5. So I have y equals 3 over 5x plus b. Well, what's my y-intercept? I don't have a y-intercept. It's nothing. My y-intercept is 0, so I could put plus 0, but I don't have to, so I won't even. So that's Sophia. This is Sophia right here. At the same bus stop, Barry boarded a different bus to school 5 minutes after Sophia. The distance traveled by Barry's bus is described in the table below. So let me go back to my website. I'm going to clear out this thing by going to reset. Oh no, will it let me? No, I just might have to refresh the website because it won't let me reset. Yeah, I had to just click refresh the website. Now notice how these points right here are different than the setup here. Okay, remember that's an x value and that's a y value. So when I type it in, I'm going to type out, 7 into my x and 2.4 into my y. So 7 is my x and 2.4 is my y add point. Now I'm going to do 9 and 4.8. And I'm going to do 11 and 7.2. I'm going to scroll up, click the line of best fit. And the line of best fit, I know it's backwards, is 1 equals 1.2x minus 6. Y equals 1.2x minus 6. So it's talking about where that they're 12 miles away. Let's ignore that first. Let's look. I mean, it says Sophia, Barry, Sophia stops first. It looks like I can ignore that part for now because it just gives me rates over here. Okay, Sophia's bus arrives at the school with a speed of 0.6 miles per minute. This is Sophia. 3 over 5 is the same as 0.6. So Sophia is 0.6 miles per minute. That part's true. Okay, and down here it says that Barry's bus arrives at school first with a speed of 1.2 miles per minute. That's true. So let's cross you out and let's cross you out. Now we have to figure out who gets there first. Okay, who gets there first? The school is 12 miles away. Okay, 12 miles away. So what that means is my y value is 12. Okay, my y value is 12. So if I have my y value is 12, 12 is going to equal 0.6x. Divide both sides by 0.6. Divide both sides by 0.6, and you will get 20 minutes for Sophia. So it takes Sophia 20 minutes to get to school. If I did that with Barry, I would say 12 equals 1.2x minus 6, add 6 to both sides, cross you out. 18 equals 1.2x. Divide both sides by 1.2x, and I get 15. So it takes Barry 15 minutes to get there. It takes Sophia 20 minutes to get there. Barry gets there first. That is an extremely challenging problem that you probably will never see. But we did it. And I showed you how, so you're now enlightened. You're welcome. Okay, that's it. Oh, that was a doozy. All right, have fun. Bye.